Hello, mic test. Okay, hello to Ken, Janavi, Destiny, Jessica, no, Jazel, Delbert, Jessica Ang, Tong En, Jice Rose, Zachary. Okay, so looks like we're good to go. Okay, welcome to tonight's Facebook Live session brought to you by Maths Heuristics. So if you haven't already, please go and download the notes from the blog so that you can follow the questions more easily. Okay, this happens every Wednesday at 8 p.m. Alright, so a bit about myself. I'm the curriculum specialist here at Maths Heuristics, and I've been working here since 2011. Then part of my job requires me to keep updated with the trends that are going on in maths questions, and also to be aware of more teaching techniques to cater to every child's learning needs. Okay. Ringo, can you try to log out and log in again? Hello to Sandia, Jonas, Mani, Edison Sim, Aggie. Hello, Nexus. Been a while. Okay, so now these heuristics that we will be sharing today are based off from the Mastering Heuristics series, which is a set of books written by my boss, Mr. Sani Tan. Okay. Why so small? Okay, hang on. And let me just show you how it's like. So these books have already been around since 2009. The first edition of the unit transfer method book was first published in 2009. Okay, and it was reprinted in 2010. Then after that, the way the book is structured is that it first gives an idea of what each technique is about. Then there is a one-shot solution to a question, and there is also explanation to explain everything step by step. It breaks down the thought processes and it highlights confusion alert for common mistakes. Okay, and to complement this, we also have an app that presents the content in a more interactive manner. Okay, so more on that later. So let me talk about. Wait, what happened? So let me talk about must know heuristics. The first part of it. Now, is your child's grade? Okay, is your child's grade still not improving, even though you think he or she knows how to apply these heuristics? Now, heuristics are problem-solving techniques for solving challenging maths problems. And most children struggle with challenging word problems because they are not familiar with the use of heuristics. So I will demystify all this and explain how to break down the questions. Now please learn the thought process. Getting the answer for the question itself is not so important, but the whole thought process of deriving the answer, that is what you need. Okay? Thank you, Mr. Jai Prakash. Okay, thank you. Okay, later on, then I'll get to that. Now, let's look at question 1. In a bag, there were, okay, please cancel this. Okay, there were red bean bags and blue bean bags, and there were 17 more red bean bags than blue bean bags. Now, every red bean bag weighed 174 grams, while each blue bean bag weighed 332 grams. And the total weight of all the bean bags is 17.632 kg. How many red bean bags were there? Okay, you're welcome, Marlene. Thank you for trusting in us. Okay, so first things first, you see that all these are in grams and this is in kg. You want to convert this into grams first. So here, okay, oh, this one is too big. Okay, I think I'll type out quite a bit because there's going to be quite a lot for me to write. Okay, convert this into grams first. 1 kg is 1000 grams. So you're going to get 17,632 grams. Okay. Now, you can see that over here, you have 17 more red bean bags than blue bean bags. This refers to your number of items. Then this over here refers to your values of your items. And of course, this refers to your total value. So when you have all these three items out, you can use number times value equals to total value, or you can also use grouping to deal with this. So once you've identified and break down what your elements are, we can proceed to deal with it this way. You got number of bags, the values of your bags, and the total value of the bags. Okay. So there's red and there's blue. Okay, so now you have 17 more red bean bags than blue bean bags. What does this mean? If you are to use one block to represent your number of blue bean bags, your number of red bean bags will be 17 more than whatever number this is. So we can say that your number of blue bean bags here is 1 unit, and for red will be 1 unit plus 17. So the values here, we can just put them in here. This is 174 grams. And this is 332 grams. Okay, so the way this works is that because you have got 1 unit of bags and every blue bean bag weighs 332 grams. The total value here would be 332 units worth. Okay. Then the next part here is the 1 unit will get multiplied by 174 first. So that will give you 174 units, and 17 gets multiplied by 174 to give you 2958 grams. Okay, so how do you visualize this? Now, if you have 1 unit of red bags, well, there's a lot of. Okay, wait, let me just adjust this first. And you have 17 more. So this is why we have 2958 grams over here. This whole thing here will be 174 units. Okay, this is to explain and visualize why you have to multiply both numbers. So once you have this already, everything over here is going to add up to 17632 grams. So what we can say over here is that 174 units plus 332 units plus 2958 is going to give us 506 units and 2958 grams. So imagine it this way. You need to remove this 2958 first in order for you to obtain 506 units. So this will be 17632 minus 2958. Okay. So this will give you 14,674. And if you have a calculator, just use it safely. This will give you 29. So 1 unit here is 29, which means to say that your number of red bean bags will be 1 unit plus 17. Okay, so 29 plus 17 will give you 46, which is your answer. Alright, so the first structure is based on number times value to give you the total value. Okay, yeah, a lot of you got it. Wait Amy, you got it. Yeah, I know Atava. Yeah. No, I'm not laughing today. Wait. Okay, you all can spam the like button first. Let me reply a few messenger questions. Okay. Okay, let me reply a few people first. They're asking how to get in. Yeah. Okay, hang on. Jialat. Why? Jialat, why you keep calling? Okay. Okay, thank you all for your well wishes. Okay, let's go on to number 2. Number 2 is where it gets a bit difficult. Now, Amy and Belinda had some savings. Amy gave 25% of her money to Belinda. And then Belinda gave 20% of her money to Amy. As a result, Amy had $180 and Belinda had $240. So find out the amount of money that Amy had first. So when you read through this question, there are two things that come to mind. The first is that this is an internal transfer because you're just passing money to one another. No money is going into them, into the total. No money is flowing out of between them. So this is an internal transfer, which means that your total amount of money is going to remain unchanged. Okay, then the second thing you will notice is that you do not know your beginning. you have two changes over here, but you know your after result. You know your end result. Hey, Unicorn, stop spamming. Okay, so if that is the case, if your end result is known, generally speaking, it becomes easier for you to work backwards. Okay? So once you have this already, let's look at the whole situation. Okay? Okay, draw out your BCA table first. Okay. A, B, there are two changes over here. Correct? And of course, there is also your total amount. Okay? Now, for Amy has got $180, Belinda has got $240 at the end. Wait, okay, very good. Some of you got it ready. Give me a while. No, it's not that answer. Okay, Unicorn, please stop spamming. So once you know this amount, we can say that 180 and $240 gives us a total of $420 between them. So at any one point in time, the total between them must always remain at $420. Okay? So now the next question is, if we are working backwards, how do we define this change over here? Belinda gave 20% of her money to Amy, correct? So when this is the case, what does this mean? We want to change this to 1/5, and then we look at the second change. What was going on over there? At the second change, this is what was happening. B gave 1/5 of her money to Amy. Means that her money can be broken down into 5 blocks of equal length. And this part was given to Amy. So when this happens, Belinda will be left with these 4 blocks over here, which is going to be your $240. So the next question is, how much did Belinda have over here before she gave it to Amy? So this part, if you draw out the model, it becomes a lot more clear for you to see. You want to take 240, divide it by 4 blocks. This will give you 60. And then you multiply it back by 5. So this would give you 300. Okay? You would have 300 over here. So how much did Amy have at this point? Amy must have had the total $420 minus $300. Okay, maybe just okay, Unicorn, please stop spamming first. Okay, then you can also observe one more thing. When you tabulate your information, it helps you organize your information and your thoughts. You can also check over here. Your A will receive 60 from Belinda. Same numbers, opposite signs, means that your total remains unchanged. So once you got it ready, the next part here is to look at this change row. At the first change, what was happening? Okay, at the first change, Amy gave 25% of her money to Belinda, which means to say that we can simplify this down to 1 out of 4, and Amy is going to have 4 blocks of money. She would have 1 entire block, and then you can cut it into 4 equal portions. So one of them was given to B. So she would be left, okay, wait, let me move my head first. One of them will be given to B. And then she will be left with these 3 blocks here, which is her 120 over here. So, when this is the case, you want to just take 120 divided by 3 blocks. Every one of this block would represent 40. Then multiply it by 4. This would give you 160. Okay? So how much did Amy have at first? The answer is just $160. But for completeness sake, if you want to check your work, you can say that 420 minus 160 will give you 260 here. This minus 40, this one plus 40. Does it check out? Yes, indeed it does. Okay? The chat is moving but your video is paused. Okay, you try to log out. You try to exit this video and come back in first. Now it's lagging. Okay, is it very laggy on your side? I may have to turn off a few apps on my computer. Okay, so anyway, let's move on. Every 10-second freeze. Okay, wait. Let me try to do something first. Okay, let me try to do. Okay. Okay, I switch off that part already. No, who is the one that is spamming all the angry faces? No, don't accuse. Do you have evidence? I don't think she would spam the angry face. Okay, never mind. Let me get find out who later on. Now there are 3 clocks in a shop. The first clock chimes every 3 minutes. The second chimes every 4 minutes, and the third one chimes every 6 minutes. All 3 clocks chime together when you walk into the shop. How many times will you hear at least 2 clocks chime together again when you are in the shop for half an hour? So over here, okay, half an hour is just 30 minutes. Let's just change that to 30 minutes. Okay, so anyway, let's look at it this way. Now, one of the common mistake here is that they want to find out the lowest common multiple between 3, 4, and 6. No, lowest common multiple doesn't work that way. Okay, at least for this question, because you are looking for at least 2 clocks chiming together. Okay, this doesn't work because this involves all 3 numbers. It is the smallest number that can be divided by 3, can be divided by 4, and can be divided by 6 without any remainder. So it doesn't work this way. You want to have at least 2. So to deal with this, you are going to have to use systematic listing. Okay, so what do I mean by this? So there's multiples of, okay, if the first clock chimes every 3 minutes, you can model it after the multiples of 3. Second clock chimes every 4 minutes, you can model it as a multiple of 4. And the third one chimes every 6 minutes, so this one can be thought of as a multiple of 6. So once you have that already, the next thing you want to do is, because you are in the shop for 30 minutes only, you want to list out all the times that the clocks are going to chime. So this will be 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. Okay, you are going to include the 30th minute in there. Okay, so no, you don't use the lowest common multiple. Then for the multiples of 4, it will be 4, 8, 12, 16, 20, 24th minute will chime again, 28th minute will chime again. So the next one will be 32. So this 32 over here, you do not include it in, because it will exceed your 30 minutes here. Okay, so the last one is on number 6. Number 6 will be 6, 12, 18, 24, and 30. Okay, so now you want to list, you have listed out everything. You want to look for the common numbers first. So at this point, you will see that at the 6th minute, okay, 2 clocks are going to chime together. No, it's not about lowest common multiple. This is a common mistake. You want at least 2 clocks to chime together. Okay, then the next one is 12. Okay, if 3 clocks chime together, that is considered as at least 2. Okay, the next one will be 18. Then the next one will be 24. And the last one will occur at 30. If you went by lowest common multiple and you just listed out 12 and 24, you're going to get it wrong because it chimed 5 times. Okay? Did I miss out anything? Okay, if you use the lowest common multiple, you're going to probably get the wrong answer, because that will be all 3 chiming at the same time. Yes, so the answer here is going to be 5. How did you get 6? Okay, how about the statement? Okay, Fiona Tan is asking a very good question. How about the statement, all 3 clocks chime together when you walk into the shop? No, the first one is, the first one, it chimes at the 0th moment. But you want to find out how many times you will hear at least 2 clocks chime together again. So it's not so much about, you will not need to count the first time that you walk in. Okay? Because your keyword here is together again. So it doesn't include the one that you have at the very beginning. Okay, so this heuristic is going to be on systematic listing. You cannot just use lowest common multiple over here because you need at least 2. Okay, so okay, thank you for the love. Okay, then let's move on to number 4. Right, now Sam won some money in the lottery. He saved 25% of his winnings and gave $1,800 less to his parents than the amount that he saved. Now, given that he spent 40% more on a computer set than the amount that he saved, and he had $3,630 left, find out the amount of money that he won in the lottery. Okay, to deal with this, allocate your units first. Okay, change this to 1 out of 4. 4 goes to his winnings, and he saved 1 of it. Correct? Then over here, the next line, he spent 40% more, which means to say that this is 2 out of 5. Keyword here is more, so be careful. On the computer than the amount that he saved. So his savings here can actually be changed to 5, which means that on the computer he must have spent 5 plus 2. Correct? So this 1 out of 4 can also be changed into 5 out of 20. So let's do that. Change this to 5 out of 20 instead, because they are talking about the same item over here. So he saved 5 units. His winnings will be 20 units. Okay. No, hey, be courteous to one another. If not, I'll ban you already. Okay. I never banned people before, but don't make me do it. So here there will be 20 units. Okay, we can say that the total is 20 units. Correct? His entire sum of money is 20 units. And he saved 5 units of money. He gave to his parents $1,800 less than the amount that he saved. So we define it out this way. Then on the computer set, he spent 7 units. So what is he left with? He's left with 3630. Correct? So if everything here adds up to 20 units, how do we go about to find out this out? So you can see that this expression itself can be quite difficult to handle. So we can use the big fat model to deal with this. Okay? The formal name is stack model, but I like to call it big fat model. So once you know this, right, what did he save? Save this amount, 5 of these. Okay, then on the computer set, he spent 7 blocks. And for the parents over here, you have got 5 units minus 1008, so it should be somewhere around here. Okay, this portion should represent 1800. And this was what was given to the parents. So where is your 3630 going to go to? This 3630, okay, this 3630 is going to come here. correct? So if this is the case, if we are to cut off this 1800 here, you can see that it's going to give us $1,830, which is also these 3 units over here. Okay, so some of you got 36,200, some of you got 12,200. Okay, we'll see in a while who is correct. So 1 unit will be 1830 divided by 3. So that will give you 610. Find out the amount of money he won in the lottery. The total number of units will be 20 units. So this will be 12,200. Okay. Okay, so what method is this? This is to use models to represent the situation, to find out what are the steps you need to take. Because you can see that some of you got 36,200. Probably that was because of some confusion. Now, Chamai, please try to refresh your screen. If your video is not clear, try to refresh it first. Okay? So we covered a few heuristics. Okay? Let me just summarize. The first one that we covered was on number times value equals to total value. How do we know about this? We want to identify what your statements are talking about first. Then the second one is going to be on internal transfer, total unchanged. And because your end result is known, you want to work backwards. Okay, for number 2, the emphasis is on working backwards. Number 3, because you have the solution over here is not immediately obvious, you want to use systematic listing. Okay, this is used when the formula is not known. There are certain pattern questions that has this issue as well. Okay, when the formula is not known, and secondly, when there's not enough information. You want to use systematic listing. So this another common way of applying this is on factors, factor pairs. Then finally, this is on models to determine what are the steps that you need to take. Okay. Now I'll be able to find out who it is. Don't worry. Well, if you have time to come here just to put angry faces, you should be using that time to do your revision. Yeah, Delbert, you are correct to say that. If you know right from the start you have to do that, you can just do that straight away. Okay, so anyway, this is the end of tonight's Facebook Live session of Must Know Heuristics, Part 1. Okay, more to come in next week. So anyway, to boost your understanding of heuristics, we have this September 2019 holiday programs being held at our premises at Gold Hill Centre. Okay, 1958 Thomson Road, Gold Hill Centre. It's opposite IRAS and opposite United Square. So this will be for P4 and P5 and P6. So for P4 and P5, these courses will be taught by me. This for P6, it will be taught by my boss. Mr. Sunny Tan. Okay? You can go and check out more details at www.mathsheuristics.com/schedule. Okay? Wait okay, hang on. Okay, you're welcome, everyone. Wait let me see if I can do this or not. Nah, I think I better not log into Facebook from here. Is there another step method that we can use? Okay, thank you, Rashida. Oh yeah, I also like to take this opportunity to thank mainly two people on our Facebook group. Okay, you can find it at this spot over here. Okay, it's facebook.com/mathsheuristics. Wait. /groups/mathsheuristics. Okay, special thanks to Miss Leslie Leong and Mr. Edwin David Go for helping out. Now I think the volume has just increased. Okay. Special thanks to them. Okay, without them I think I'll really have to sleep in my office really. Okay, you're welcome, Cecilia. Yeah, you're welcome, Yip. Thank you for your well wishes. Okay, you're welcome, Ringo. Adeline, there are a lot of faster methods. That one, actually, there is. Okay, wait Why I cannot? Okay, bye bye. You all have any questions for me? I'll take them now. You're welcome, Elta. Okay, let me try to figure this out first. Memes No, nowadays the memes all like quite outdated already. Delbert, the faster method is what you mentioned. That is the faster method already. Okay, wait. Memes nowadays. Stonks. Stonks. The stonks meme is like kind of extinct already. No one is really using that. Stonks I know lah. I know. What are stonks? Stonks is this fella. He's like folding his arm. And then there's this chart going up. And there's this word called stonks. Area 51 meme is gone already. Then what else is there? Say site right now is also gone. Popular ones are Minecraft memes, but I don't play Minecraft, so I'm not really sure about that. Area 51. Okay, what else is there? What else is there? Minecraft. Team Fortress 2. Okay, let's not talk about that. Hey. Creeper. No, Fortnite is dead. Fortnite is dead. Okay, that is like... Wait. What is Tenopy? Tenopy is a platform where we conduct our live online classes. Why everyone likes memes so much? There are a lot of dead memes recently. You don't see them trending anymore. What was my hardest subject in primary school? Chinese. Chinese language. Always had a problem with languages. Okay. Momo is just creepy lah, but it's also kind of dead by now. A lot of memes are dead already. Stonks. What other things are there? Okay, see you all soon. Yeah, let me go and read up more on memes. Every morning I will go and look at memes. Like how your parents look at the newspapers, I will go and look at memes. But I can't really think of any solid ones recently. Okay. That depends on whether or not I can teach Sec 1 it depends on whether the company wants to expand or not. But we also have certain constraints, so we can't really go into Sec 1 at this point. Okay? Yep, your September holiday coming very soon. Have fun. Okay, anyway, if there's nothing else, then this is Kevin from Heuristics signing off. See you all soon. Memes. Okay, we're gonna do stonks like your math result. Okay, your math result is gonna be like stonks. Then you'll be like this. Okay, see you soon. Bye bye.